Hello, my name is Davis Banger. Let's talk about power series. Today we will be looking at problem 7 of the 10.2 handout, in which we will consider the power series the sum from k equals 1 to infinity, 1 over k 3 to the k times x minus 2 to the k. We will find the radius of convergence for this power series, and then differentiate the series to find a power series representative for the derivative. Fix a value of x. We will check and see if the series converges at this particular value of x using the ratio test. Recall that for a series the sum from k equals 1 to infinity a sub k, such that the limit as k goes to infinity, the absolute value of a sub k plus 1 divided by the absolute value of a sub k exists and is equal to L, then this series converges if L is less than 1, diverges if L is greater than 1, and the ratio test is inconclusive if L is equal to 1. In our case, we will perform the ratio test for this particular fixed value of x. The limit of the absolute value of the ratio of our terms is equal to the limit as k goes to infinity, 1 over k plus 1, 3 to the k plus 1 times x minus 2 to the k plus 1 divided by the absolute value of 1 over k 3 to the k times x minus 2 to the k. Now we can pull out of this expression the x minus 2 to the k plus 1 and the x minus 2 to the k, taking the absolute value of each. Now examine the first terms here, k plus 1, 3 to the k plus 1, k, and 3 to the k. We only consider positive values of k when we take the limit as k goes to infinity. For each of these, if k is positive, then the term itself is positive. K plus 1 is positive, 3 to the k plus 1 is positive, k is positive, and 3 to the k is positive. Hence, we can drop the absolute values on these terms. In the remaining terms, the absolute value of a quantity to a certain integer power is equal to the absolute value raised to that power. So we are left with the absolute value of 2 to the k plus 1 divided by the absolute value of x minus 2 to the k. Now, we can simplify this as follows. By grouping the k over k plus 1 together, this simplifies to 1 over 1 plus 1 over k. We have 3 to the k in the numerator and 3 to the k plus 1 in the denominator. This simplifies to 1/3. Analogously, the final term simplifies to the absolute value of x minus 2 because there are k plus 1 copies in the numerator and only k copies in the denominator. Hence, the only remaining term with a k value is the 1 over 1 plus 1 over k term, and as k goes to infinity, this tends to 1. Hence, our limit is 1/3 the absolute value of x minus 2. And remember, we're taking the absolute value of x minus 2. Thus, the series will converge if 1/3 the absolute value of x minus 2 has value less than 1. This will happen when x is between -1 and 5. Thus, the radius of convergence is 3. And if you're having trouble understanding how we arrive at the term radius of convergence here, you can think about a circle. The circle, we have the diameter, and the radius is the distance from the center to the edge. Now here, we could say that make a term up and say that the diameter of convergence is 6. But the convention is that we talk about radius of convergence, which is exactly the distance from the center. So that's going to be 3. Alright, 7b. Remember 7b, we were asked to take the derivative of the series, and we'll do that by taking the derivative term by term. So a general fixed k term will be 1 over k 3 to the k x minus 2 to the k. After we differentiate this using the power rule, we get 1 over k 3 to the k times x minus 2 to the k minus 1. which simplifies to 1 over 3 to the kx minus 2 to the k minus 1. Thus we can find the power series for the derivative as the sum from k equals 1 to infinity 1 over 3 to the k times x minus 2 to the k minus 1. And if we're interested, we can re-index so that we have only k powers here. Alright, thank you for watching. And as always, you can reach me by leaving a comment below or emailing me at binger@math.ohio-state.edu. Thank you, and have a good evening.